Hey guys, it's me, Mrs. Rice. This video is going to discuss properties that we would commonly use in proofs. So that's what this video is about. Some of them you've seen because of Algebra 1 and some of you haven't. So we'll start with the things that you have seen before. So properties of equality. So addition property, subtraction property, multiplication property, division property, and distributive property. You've seen all of these phrases in Algebra 1. You may not have known that this is what you were using to solve for certain things, but these specifically you have used before. So I will show you these properties, or at least the first four, using this information here. So if you know that A equals B, you can use the addition property to say, hey, if I add the same thing to both sides, the equation will still be equal. So A plus, no, there we go, 2 equals B plus 2. That can also work if like C and D were equal, because then you could say like A plus C equals B plus D, something like that as well. It doesn't necessarily have to be numerical values that you're adding to both sides, as long as it's the same exact thing that you're adding to both sides or equal things. So subtraction property is the same thing, only you would be subtracting from both sides instead. So I'll use the 2 again. So A minus 2 equals B minus 2. So you would use this property to say that exact statement. And just like before, and with all of these, it doesn't have to be numerical numbers. It could be variables as well. It doesn't need to be numerical values, as long as what you're doing, whether it's adding, subtracting, multiplying, or dividing, is the same thing to both sides. So multiplication property, I could do A times 2 equals B times 2. The division property, I could do, A divided by 2 equals B divided by 2. So these properties are the justifications for the actual operation. So if A equals B has to be somewhere in the proof, you need to know that A and B are equal before you do any of this. And then distributive property, typically we've seen distributive property like this, where we literally take the number in front of the parentheses and multiply it out to both items like this. So distributive property would be the explanation if we did something like 5x minus 15. Distributive property could also be used to go backwards, meaning to factor out. So if you had this, the 5x minus 15, already in your proof and you needed to factor out for some reason, like this line right here, 5 times the quantity x minus 3, that reason would also be distributive property to go from here to here. They also use distributive property to simplify like terms. So instead of saying combine like terms, you may see distributive property instead. So those are the properties that you've seen and may not have known it. Other properties of equality, there's 4 of them here. You've probably seen one of them because we know what substitution is, but reflexive, symmetric, and transitive you may not have seen before. So I'll talk about reflexive first. So reflexive property is to identify that the same item is equal, and a geometry example of that could be that 2 items are sharing the same side, so you want to identify that that side is the same even though it's 2 different figures having it. So what you'll see with the reflexive property is the left side and the right side of the equal sign will have the same exact thing. So like A equals A is an example of the reflexive property. So I always like to tell students it's like looking in a reflection. It's the same thing. You're seeing yourself in a mirror. So the reflexive property is the same thing on both sides of the equal sign. The symmetric property is used to switch things around. So if things weren't in the correct order, for instance, say in your proof you had that A equals B, but what you were trying to prove is that B equals A, then you can use the symmetric property to do that. So the symmetric property switches the location of things across the equal sign. So the thing on the left goes to the right side and the thing on the right goes to the left side. So again, this should be somewhere, this A equals B should be somewhere in your proof prior to you switching. The symmetric will only do this. It will only switch it for you. Okay. So transitive. Transitive property, you'll see like a chain of equal things. So in your proof, they'll say something like this. 2 items will be equal, and then you'll see that one of those items is equal to something else. You can use a transitive property to say that the first thing and the last thing are equal. So the thing that's repeating, in this case it's the B's, would be removed and the equation would be restructured so the first thing and the last thing are equal. So it resembles substitution, but it's not substitution because it's a chain of things that are equal. So you're removing the things that are the same exact thing and restructuring the equation to make them equal, the first and the last. So this would be the statement using the transitive property in your proof, if you had stuff like this in your proof. And then substitution is like, oh, if A equals B, anywhere in your proof, you could hypothetically replace B where A is or A where B is. You can also do that with numerical values. If A was equal to 8, for instance, you could replace A with 8 instead, or 8 with A if that was needed in some way. So that's what the substitution property tells us. Now, if you look, reflexive property, symmetric property, and transitive property could also be properties of congruence, meaning instead of using an equal sign, you could use a congruence symbol. So if I wanted to give you examples of these, I could say like angle A is congruent to angle A for reflexive property. See if I could write that. It's going to be really messy, guys. So angle A is congruent to angle A. This is really hard to do without like a separate mouse. Okay. Symmetric property, again, of congruence. The only difference between these equality ones and the congruence ones are your symbols, really, and, you know, proper notation with congruence versus equality. But symmetric property, you could say something like, if you know, let's see if I can type this. So if you know that like segment AB is congruent, ooh, where are you? Here you are. Is congruent to segment CD. We can use symmetric property to say that CD is congruent to AB instead. Here, and I'm going to put correct notation for us. So I know that this gets a line segment anyway, and that gets a line segment above it. And that one does as well. And this one. Because we know the minute that we use the congruent symbol, we have to put the segment notation above the letters because we're not talking about lengths anymore. We're talking about the segments themselves. So keeping with that same example, if we wanted to use a transitive property in congruency, it would be something like if AB is congruent to CD, and you knew that CD was congruent to EF, then you can say that AB is congruent to EF. So that's how you would apply transitive in that case. Line above, line above. Ooh, that's awful. Sorry, guys. Line above, line above, line above. It looks like an arc, sorry, line above. Okay. So, things to take away from this. Reflexive property, symmetric property, and transitive property can be used in either congruence or equality. Looking at equality properties, substitution is only an equality property, as well as addition, subtraction, multiplication, division, and distributive. These are only equality properties because you can only use these with equal signs. All right, guys, I hope this was helpful. We'll discuss this more in class. Have a great night. Bye.